Hello everyone, I am Madhuri Gupta, second year MCA student at IIPS DAVV Indore. It's my assignment video and I am going to explain you about a very interesting topic of discrete mathematics, that is digraphs and shortest path algorithm, and also we discuss different methods to find shortest path with the help of digraphs. So let's move into the video. So in this video our topics to be covered are introduction, digraph, application of digraphs, ways to find shortest path, Digraphs algorithm, BFS and DFS. So let's begin with the introduction part. Introduction to digraphs and shortest path algorithms. Directed graph or digraphs are powerful tool for modeling complex systems with relationship between elements. Shortest path algorithm like Digraphs find the most efficient route through these networks with application in transportation, logistics and many more. So let's see the actual definition of digraph. Digraph or directed graph. A directed graph G is a graph in which the edges, that is E1, E2, E3, E4 till En, are directed by arrows and its vertices are denoted by V. It also called directed graph. For example, the ordered pair Vi Vj means an edge between Vi and Vj with an arrow directed from Vi to Vj. So here you can see in this figure, E1 is directed from V1 to V2 and E2 is directed from V2 to V3 and the E4 is V2 to V4. Here is another definition of digraph. Digraphs have edges with a specific direction indicating the flow of information or movement between the nodes. They are useful for modeling one-way relationship such as in social network or transportation networks. Let's move to the properties of digraphs. Digraphs have unique properties such as in degree, out degree and reachability, which are important for understanding the structure and behavior of the digraph or a graph. So here you can see we have three methods to find the shortest path algorithm. Our first method is Digraphs algorithm, second one is BFS, that is breadth first search, and the third one is DFS, depth first search. So let's move into the first method, the Digraphs algorithm. Our step 1 is greedy approach. Digraphs algorithm uses a greedy approach to find the shortest path by always selecting the node with the smallest distance from the source. Our second step is step-by-step process. In this process, mark all nodes are unvisited, set the initial node as the current node. Our third step is calculation. For the current node, consider all visited neighbors and calculate their tentative distances. Update the tentative distance if smaller value is found. So our second method is BFS, breadth first search. In this method, firstly we explore neighbor first. BFS visits all the neighboring nodes at the present level before moving on to the nodes at the next level. So our second step is queue based algorithm. BFS uses a queue data structure to keep track of the nodes to be visited. Our third one is useful for shortest path. BFS is effective for finding the shortest path between two nodes in an unweighted graph. So let's move into our third method, that is depth first search. In this method, our first step is explore deeper. DFS visits the deepest node first before backtracking and exploring other branches. Our second step is stack based. DFS uses a stack data structure to keep track of the nodes to be visited. Useful for topological sorting. DFS is effective for tasks like topological sorting and finding strongly connected components. So let's discuss application of graphs in real-world scenarios. Graphs are used in pathfinding, social network and recommendation engines. So in the pathfinding, graphs are used to model road network, airline routes and public transportation system to find optimal path and schedules like GPS navigation, route planning and traffic management. In the social network, graphs are widely used to model, complex networks such as social media, communication system and transportation networks. In recommendation engines, graphs can be used to build recommendation system that suggests products, content or connection based on user preferences and relationships. So let's move into the conclusion part. Graphs and graph algorithm are powerful tools for modeling and analyzing complex systems with interconnection elements. From transportation and logistics to social network and recommendation engines, graphs provide invaluable insight that drive efficiency, personalization and innovation in real world. It's all about my side in this video. If you see my video informative, please like, share and subscribe my channel and do comment in comment section. Thanks for watching.